Hello everyone. Today's question is linked list cycle. So let me read quickly question for you. Given a head, the head of linked list determine if linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tells next pointer is connected to. Note that position is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So let's analyze the given test case 1, which is example 1. So we have a given linked list and head is pointing to the first node of the linked list, and let's traverse the whole linked list. So 3 is next pointing to the 2, 2 is next pointing to 0, 0 is next pointing to -4, and -4 is again pointing to the 2 which is previously visited. So from this example, uh, the from this example, my approach is to maintain a hash set, and in this hash set, I'll just insert the every node into that, and whenever I'm on this node, let's say I'm on the 0 this node, and first of all I'll check my hash set if this node is previously visited or not. If this node is previously visited, then I'll return true, otherwise return false. So let's try to implement. So let me write the approach here, which approach I'm going to use. The first approach is using hash set. Okay, so let's code it. So we need a unordered third set. It will be list node, and let me name it as a visited. Why we are using we are storing list node? Why we are not using uh, value of node? Because value of node can be duplicated. Duplicate also might be present in the linked list. So that's why we are not using. Let's create one more list node current, and it is assigned with head. Let's traverse the linked list. Okay. Uh, Before inserting into visited uh, hash set, let me check if visited dot find if the current node is in the set. That means there is a cycle. So visited dot and then we will return true. Otherwise, we will insert. So visited dot insert the current node, and after whole linked list is traversed, then there is no cycle, so return false. So this is the approach one, and this the time complexity of this will be big O of n, where n is the node. Okay, we are getting an error. Okay, head is 1 and position is -1. Okay, head is 1 and okay, I have to also move the current pointer will be current to next. Okay, now the error. Okay, it's correct. So I'm saying the time complexity of this solution will be big O of n, and n is the number of node in the linked list. Because we are visiting the node at once, every node at once, so it will be big O of n, and the space complexity will be also big O of n because we are storing every node into visited. In the worst case, uh, the linked list means the given linked list is not a cycle. So in the worst case, it will be storing all the nodes into hash set. So the time complexity, space complexity of this solution will be big O of n. We can do better. Uh, we will use the algorithm. There is famous algorithm called Floyd cycles algorithm. I think I'm correct. Yeah. So we can use in that In that we will use fast and slow pointer and slow pointer. So let's try to code it. The basic idea is to I will be point both slow and fast initially at the head, initialize with the head, and I'll move the fast two steps ahead and the slow will move one step ahead. If they meet at the same node, then there is a cycle. If they doesn't meet, if they do not meet, then there is no cycle present in the linked list. So let's do that. List node fast initialized with head and list node slow head. It is also initialized with head. We will check if fast e is not equal to null and fast ka next, because we are moving two steps ahead, so we have to check fast ka next is not equal to null. Then we will do fast equal to fast ka next and slow equal to slow ka next ka, sorry, it will be move one step ahead. So now we will check if fast equal to slow. If it is, then we will return true. Otherwise the whole traversal is done, then we will return false. Okay, why we are not putting condition of slow into while loop condition? Because slow is behind the fast, so fast is ahead, means it's ahead of the slow, so that's why fast will reach first null, then we will reach before the slow. That's why we are only writing the condition of fast and fast connects. So let's try to run this. This is the very famous approach of solving fast and the slow pointer. You should read. Let me try to submit this and see if it is running fine or not. Yeah, it is correct. So let's try to, okay, it's correct. Thank you for watching.